Hey everyone, welcome back to my channel. As per the thumbnail, you would have seen that in today's video, I'm going to showcase you about different React design patterns. And the plus point is that I'll explain you about the two examples. One is a normal example for an application and another one is an AI-based real life examples. If someone asks you in a React interview, how do you structure scalable React applications? And if you only answer useState and useEffect hooks, then you are probably missing what interviewers actually want. Today, I'll explain the most important React design patterns with example and when to use each one. By the end of this video, you will know what each pattern solves, interview answers, real world examples, and so on and so forth. So let's get started. The very first design pattern is the container slash presentational pattern. Ideally, this pattern separates business logic from the UI logic. Now, if someone asks you why you want to separate the UI logic from the business logic, a simple answer is to improve the maintainability and reusability of the code in the application. We can take an example of the dashboard page where we have different dashboards representing different informations. Like one, we have dashboard representing the pie charts. Another, we have the dashboard representing the KPI charts for line charts or stacked column charts. So those charts are representing different informations. We can use the container patterns when components become complex and hard to use. And the key benefit is that it is reusable and separation of concerns. If you see the example here, we have a container function and we have a presentational function. The user container is having user state hooks and it returns the user view. Now we are passing the user view as another function in the UI where we are showcasing the username. So here we are separating the backend logic, which is the business logic, and the presentational logic, which is the UI logic. The dashboard example is a real life example. Now I will showcase to you the AI based example. Yeah. So the AI based example represents the ChatGPT clone. Suppose we have a ChatGPT clone which is handling, we have a container in the ChatGPT clone which handles API and state, and the presentational renders UI, which means in the backend we are calling suppose we are calling the LLM APIs or OpenAI APIs, Gemini APIs, which is managing all the load and the error states, and it passes the data to the UI components. And the UI components are representing all the different sections of the charts. So this is how you segregate both the backend layer and the presentational layer. Now coming to the another pattern, which is higher order components. In HOCs, ideally, a function takes a component and it returns a new component with extra properties and logic. Suppose, if you see the example here, we have a function named withAuth and it is uh, passing a component which is wrapped component as an argument. And we are returning that wrapped component with an extra properties and that properties is getting passed in the another function. If you see here the usage, it will be usaged when we want to use the code at different multiple components. And also we can use HOCs when we want to do authentication or SSO authentication, logging, or we can use it in feature flags. Suppose we want to mark as var is flagged is equal to true. And then in some of the functions or methods, we can mark it as false based on the conditions. So that is one of the use of the higher order components. Let's discuss the AI example of the higher order component. Suppose we have an AI app with a role-based access. A role-based access can be in, suppose you are taking ChatGPT Pro, which is a subscription-based model, and based on that you will be able to access different features. Features like you can access AI email generation, PPT generations, video generations, and some extra other features. Ideally, it can be used for authentication and root guards. It can provide some role-based access control, analytics, and logging injection, which is basically the features which we are getting in premium access. So that can be a good example of using higher order components in React after upgrading a particular AI model. Now coming to the another pattern, which is render props pattern. Ideally, this is used to share logic using functional props. We can share code between component 1 and component 2 using functional props. And when can we use the render props pattern? When you need to share a stateful logic. For example, a mouse tracker. If you see here, it is showcasing a data provider example, passing data props and having UI data is equal to data. It is a highly reusable logic. If we check out the example here, we have a function data provider in which we are passing children. In that, we have a data provider component. We are passing a user list here where data is equal to data, and we are setting this data with a user state hook passing as an array. And using the useEffects, we are fetching the data and then passing the children. So ideally, we are passing this function prop inside another component, and that's how the property pattern is getting used. Which do you think is more suitable to use now? Is it render props or higher order components? Ideally, a more explicit to use is render props, but I think it can increase nesting. You can let me know in the comment section below which will be more preferable to use, render props pattern or higher order component. Now let's check out the AI example for it. Yeah, in the render props pattern, ideally it is used to share the logic via functional props, which is more flexible and composable. In the real product example, we have an AI model selection dashboard. Suppose in the Gemini, when we are using Copilot, GitHub Copilot, we have the option to choose the models which we want to use based on our terms and conditions. We can choose GPT 4.5 Mini, Claude Sonnet, Cloud Opus. So here also we have the option to choose the models. Which model we want to use, whether we want to use Gemini, Claude, or a GPT. Although the logic is shared, so the UI stays flexible. So no higher order component nesting complexity is there. So this is one of the examples of using the render props pattern, where the code shares the logic via functional props. Now coming to the another design pattern is custom hooks pattern, which is used to extract reusable state logic. For example, use fetch or use auth uh, hooks. Custom hooks are basically, suppose we have two components, component 1 and component 2, and both the components want to use the same code, which has been already implemented in component 1. If we want to use the same code in component 2, then we can use the useFetch hook and implement the similar logic from one component to another component. If you see here, we have the useFetch function and a logic has been written there where we are returning the data which has been passed in the user state hook. Now that function we are using to fetch some of the APIs of users. So in this way, It is passing one of the logic in another component. Which do you think is more flexible to use? Custom hooks pattern or higher order components? Let me know in the comments below. I feel hooks are a better way to be used in today's time, but still HOCs are getting used still and they are existing. Let's go to the AI example now. Yeah, so coming to the custom hooks pattern, the AI example showcased here is the prompt generator, which is a chatbot. We can imagine the prompt generator chatbot in ChatGPT, used in ChatGPT or Perplexity or Cursor for reusable API calls. When we are passing a prompt, ideally it is going the responses they which are a sequence of tokens, they are going to the LLM APIs, and the API is being called, which is used to fetch the data from a set of large data set and then gets responses. It can also fetch the data from the caching and loading states, and it is 100% reusable across components. So this is one of the best examples for the custom hooks pattern, showcasing the API calls which are happening from the backend. Now coming to the another pattern, which is context provider pattern. Basically, we use this to avoid prop drilling. We have a global state or a global data or a global property variable which has been provided to the component tree to be used by multiple. We have a global data which has been provided to the different components of the component tree, and it can be used by any component, component A or component B or component C. Ideally, if we want to use context APIs, we can use that as well to avoid prop drilling, and where we want to pass the properties from parent class to child class. If we see the example here, we have created a const theme context which is equal to create context. Then we are passing and creating a provider which where we are passing the theme, and then we are using the use context to pass the theme context. This is an example of a theme authentication language. Now let's see the AI example for it in the context provider pattern. Suppose we have an AI SaaS dashboard where we are using to store themes. It could be a dark theme or a light theme, then model selections and user credits globally. Suppose we are having 10 credits given to Claude to be used per day. Now, those 10 credits, we can perform multiple actions. We have global AI model selection, like suppose we are using Claude Opus to generate and solve some complex problems, write codes. Then we are using some Claude Opus model to create a PPT presentation. Then if we are working on some theme and local settings to change the dark theme and the light theme for a website creation, which we have done, then we can use those credits. Suppose all those credits are gone. We need to wait if we don't have a pro plan. So that is how the context provider works. Ideally, we are getting provided with the credits here so you get it used in the most optimized way, which is a and the credits here are acting as a global variable or global props which can be used in the component tree and avoid prop drilling. Now let's get to the next pattern, which is compound component pattern. Here, components ideally communicate implicitly. The components work together and share a state implicitly, which is basically used in building flexible and reusable component APIs. Suppose we have tabs. Now we have different flexible component APIs. Like we have tabs showcasing tabs.list, tabs.tab, and tabs.panel. Why use components? Ideally for making flexible APIs. If you check out the example here, we have a tab stack in which we are implementing the list of tabs and then we are creating the panels. We can have two panels, profile, content, settings, content, and then we have tabs list. We have the tabs list for profiles and settings. Coming to the AI example, suppose we have a chat interface. The components here share implicit state via context internally. We have a flexible layout API. Subcomponents share a state. It is used in ChatGPT or Notion on Linear. Suppose we have a chat interface. It contains the header sections, it contains the messages sections, history, chatbots, inputs, and actions. The actions which we have performed, which means the prompts we have given, which has been saved in the chat history, and the chat history, which is getting saved in the backend APIs or in the vector DBs. So this is one of the good examples of using the compound component patterns in React. Now let's get shifted to the next pattern, which is a state reducer pattern. State reducer pattern is basically used to implement the use reducer hook and perform complex state transitions using those hooks. Complex local state with multiple subvalues. Ideally, we have three parts. One is the action to perform some of the tasks, and then one is the state, which is used to manage the state of an object, and another is the reducer, or you can say dispatch. Dispatch is used to dispatch the actions to the states. In simple terms, if you want to understand, is basically it is used to perform complex state transitions. We are showcasing the action, reducer, and then new state. Suppose if someone asks you why you want to use reducer instead of useState hooks. Ideally, both are trying to change the state of an object. But using use reducer is basically used if you want to perform multiple state transitions for larger scale application. It can be helpful in that case. The key benefit of using this is to have predictable state updates. If you check out the example here, we are trying to increment or decrement the state count. We have the state of an object and we are trying to perform an action in which we are trying to increment the count or decrement the count of the state. Coming to the AI example, we have a AI workflow builder where in the user flow, we are uploading some files, giving a prompt, and then generating the responses and then reviewing the states. It is idle, loading, and then it gives you a success or an error. It is performing a complex task, and based on that, it will give you the response. So this is one of the examples of a state reducer hook, which is easy to debug and test. Now coming to the last pattern is the controlled and uncontrolled pattern, which is used in the form modules. Ideally, it is used to handle the form inputs in React. Coming to the controlled, in the controlled, the React controls the state in the controlled components, and in uncontrolled components, the DOM controls the state. You can see here, it gives better control or better performance if we use such patterns. In the controlled case, we are using the useState hook, and in the uncontrolled, we are using the useRef. The AI example is giving an AI prompt input. Suppose live token count needs controlled and 5 upload is uncontrolled. In the controlled components, we are giving live token counting, which specifies that the React controls the state, and uncontrolled is we are uploading some file and then working on the performance. Choose based on UX and re-renders. Now, which performs better out of the controlled and uncontrolled? It also depends on the complexity. These were the ideally 8 React patterns which are mostly used, or I would say majorly used. And the other popular patterns which I would like to mention, which also helps in the performance management of the React applications, can be lazy loading to load the applications after some time, which are actually not required in the initial phase. Prop drilling, which we have discussed in the context provider pattern, passing the props from parent to child, and code splitting the code or refactoring the code if a large file has been created. error boundary pattern, debounce and throttle pattern, memoization techniques to avoid re-renders and memoization or heavy calculations, and optimistic UI patterns. These are also some of the good ways of working in React. Now, these are some of the interview tips which I would like to mention. Answer every design question using what is it, why it has been used, what are the pros and cons of using these patterns, and also some real world use case examples, which will be easy to explain, and compare it with alternative approaches. Keep your code short and clean. I have also showcased some common interview questions here, like what are the difference between HOCs or render props, HOCs or custom hooks, benefits of using some of the patterns like custom hooks or use reducer hooks, React memos, how to manage the state of large applications, and difference between the controlled and uncontrolled components. You can go through it and let me know if you have any queries regarding any of the patterns. You can let me know in the comment section which React pattern actually confused you the most. This was all from my end explaining the React patterns. If you liked this video, give it a thumbs up, subscribe to my channel, and comment about the feedback. Thanks for watching till the end, and see you in the next video.